It's just a revision. I've explained it the other class. Read. That's clockwise direction. This person's weight can go like this. That's clockwise direction. So now, but if they are not moving, they are in what? Equilibrium. I told you that saturated solution where you are going to reactant and product at the same time is an example of what? Dynamic equilibrium. An example of equilibrium. Saturated solution. Deposited at the same time, and some are dissolving, some are also coming out of the solution. That was them like depositing. Now at the same way, What an example of volatility when you have bromine. I show you bromine the other day. Bromine is a liquid. It can become gas, vapor easily. That's why they call it volatility. A liquid that can easily become what? Vapor. Now, you can see some vapor in the container that day. And we also see the bromine also. You see the reactant and we see the product. Oh yeah. Now, some gaseous bromine are becoming liquid, and some liquid bromine are coming towards gas. Vaporization of bromine. Now, this it will be constant, no netching. Can you see? I showed you this diagram last class. Now, this is at the green. You can see vapor and bromine liquid inside that same container. So as some vapors have become condensed means when vapor become liquid, condensation. Some vapor are becoming liquid back, and some liquid are also becoming vapor back. Now, look at example of reversible reaction. Sulfur oxide plus oxygen to give sulfur 6 oxide. Nitrogen gas and hydrogen gas to give ammonia. Iron and what? Water. Heated iron. I get it. Iron and threaded steam. This is a steam. To give iron 3 oxide dye 2 iron 3. Iron 2 iron 3 oxide. I get it now what? Hydrogen what? Gas. This is not a rusted iron. I get it. Please take note. Now become vapor direct. Now ammonium chloride is a sublime product. Is a sublime what? Substance. Become what? Vapor. I get it now. That's become ammonia and what? Hydrogen chloride gas. And those gas can also combine together to become more solid. When a solid moves to gaseous state, direct without liquid state, is a that process called what? Sublimation. Combine together to form what? Ammonium chloride. When cooled, when you cool it will go back. When you heat it will go to the front. I get it now. When you apply it will go to the front. When you cool it will come back again. That's a reversible reaction. A reaction that can be reversed. Forward, I can achieve forward reaction. This forward reaction, the product side is the forward reaction. The reactant side is the backward reaction. That's it. Please take my hand. Now, this is so you can shift this. Now, what you want to shift this back. This is a reversible reaction. A closed system. A system whereby nothing can leave and nothing can enter. That's a closed system. This is the desiccation reaction. Alkaloic acid plus alkanol to give alkanoates and water. That process is called what? Esterification. We'll start organic chemistry soon. Oh yeah, let's go on. Forward or backward reaction. So esterification process is a reversible reaction. So therefore this kind of reaction is in what? Equilibrium. Yeah, and this is one of the signs you are going to see there. I like everything now. See those products are reacting, you see it there. That kind of system is in equilibrium. A catalyst does not now. It takes you to achieve equilibrium in time. That's what catalyst does. I get it now. Question. Some are not talk like that. The system must be closed. I told you that if the free energy chain is zero, that is in what? Equilibrium. What if free energy is negative? The reaction is spontaneous. If free energy is positive, the reaction is not spontaneous. I told you energy and chemical reaction. Assignment. I gave you the assignment. I'll check that one tomorrow. Energy and chemical in your learnings. I taught you that. The calculation and the theoretic part, everything, isn't it? Some people have seen some my students, they have done it. I get it now. And some have not done it. If you have not done it, Saban, you have to do it. Don't forget to do it again. No? Where is that person? Where is that boy? He's still there. No, you are still owing me. I'm coming. Don't forget your note again. No, don't worry. Energy and chemical, and still read it also. I get him now. We are trying for you. Mr. Gideon assignment also, I will ask for it on Friday. All what he has taught you, wave, biology, chemistry, everything he has taught you in chemistry. And Mr. BG also. We are trying for you. You guys are enjoying. Wallah. Oh yeah, let's go on now. Sorry, let's answer this question. No. Position of code and reactor must be equal. I get it now. So this way, this is wrong. The position of reactor and product remain constant. It does not change. Option C. I get it now. Option C. Reactor forming. No. Option C is the right answer. Good. Equilibrium constant. Oh yeah. Read. Or before you go to equilibrium constant, I'm going to factor affecting equilibrium. Before I go, I will come back to the equilibrium constant. I will come back to this equilibrium constant. Le Chatelier's principle. Okay, let's go. If you apply a temperature, maybe temperature of this system, of this bromine temperature is 80 degrees Celsius, assuming the temperature of this bromine liquid is what? 80 degrees Celsius. Now you are the one that apply it, right? Is this reaction when you apply it to the bromine, is it endothermic or exothermic? It's endothermic now because bromine, it is applied. When it's applied to the system, so it's absorbing from the surrounding, right? That's what endothermic, right? Now, so bromine liquid forms what? Bromine vapor, right? Now, when you now reduce the temperature to 40 degrees Celsius, I get it now. What's going to happen? And this is the temperature you reduce to 40 degrees Celsius. What's going to happen? You have reduced the temperature. More vapor will become liquid because you have reduced the temperature of the system. More vapor will become what? Liquid. Because of this one will not become vapor again because you have reduced the temperature. The heat is not like before again. So more vapor will now start condensing back to liquid. More vapor will start what? Because because of high temperature, that's why bromine keep what? Becoming what? Vapor. So when you now reduce the temperature, now the temperature is not high again before. So now we will not have much bromine liquid again. So for you to have much bromine liquid again, bromine vapor must be condensing. That when I condense must be becoming what? Bromine liquid back. That's mean of condensation. Therefore, the equilibrium is now shifting to the left. It's now what? This is your left hand side, right? It's shifting to the what? Left. Or I can say backward what? Backward reaction. Am I communicating now? Because of the temperature was what? Reduced. So now, if this temperature is one of the factors that affect equilibrium. Temperature is one of the factors that affect what? So now that's what the principle is saying. State that if a chemical system is in equilibrium and one of the factors involved in equilibrium is altered, is changed. I guess now maybe I increase the temperature or I reduce temperature. Now the equilibrium is going to shift. I get him now. So as to what? Or neutralize the effects to cancel the effect of that change. So as you try to remain in that equilibrium. I get him now. Now because it wants to remain in the liquid, now more vapor will go back to what? Liquid. Because you have reduced the temperature. I get him now. So backward to shift to the what? The equilibrium will shift to the left. I get him now. So as to annul, that's to cancel or to neutralize the effect of the what? Of the change. We have class state relation. It's very important. The state is state. Is altered. What is altered? Is changed. Sit up. I can't hear you. Annul or neutralize the effect of the what? Of the change. The chemical system is in equilibrium. One of the factors is change. You can also use change. One of the factors is altered. The equilibrium what will shift. So as what? Annul or neutralize the effect of the what? Of the change. Now that's it. Now this one is very important. What are the factors affecting equilibrium? Temperature. Now, and this pressure works for gas only. Pressure works for what? Now, concentration and temperature can work for liquid. I get it now, solid. Let's go now. Note, very important. That's what a catalyst does. It doesn't affect equilibrium position. Now, what's equilibrium position here? Now, if I reduce the temperature, the equilibrium will shift to the right, left. It is at the left. Now, look up now. But catalyst affects the chemical reaction, right? It speeds up and it can also reduce the rate of chemical reaction based on what kind of catalyst you use. You have positive and negative catalyst, right? Positive catalyst speeds up the rate of chemical reaction. While negative catalysts are what? They reduce the rate of chemical reaction, which means they are also called inhibitor, negative catalyst, isn't it? Now, let's go. Now, where am I now? Where am I? Thinking. Yeah. Okay. Effect of temperature. We want to study effect of temperature now. When you exothermic, your heat change the what? Positive, right? The heat that because more heat is absorbed, right? So now, or exothermic, your air temperature will be what? Negative. This one is exothermic. That bromine liquid, I don't know increase that temperature to 150 now, more vapor will be what? More vapor will be formed. I get it now? Now look up, listen very well. Fabale. For an endothermic reaction, an increase in temperature or what? Favor forward reaction. Now, when you increase temperature, forward reaction also means progress. Forward reaction also means what? Progress. Where is Favour Adeshewa? When you increase temperature, is also what? Progress. Forward and endothermic what? Reaction. Forward reaction and the equilibrium constant will also what? Increase. We use capital letter K to represent equilibrium constant. I get him now. It will what? It's going to what? Increase. It will increase. The equilibrium constant will increase. And what is the equilibrium constant? Is the ratio of concentration of the product over reactant. Don't worry. If I have something like this, reactants to form products C plus D. Maybe I'm having small letter C here, small letter D here, small letter P here, small letter A here. If you say equilibrium constant is the ratio of the products. What is the product? Concentration is the ratio of the concentration of the product. Concentration of the over concentration of the what to the reactant. I get you now. This is small letter C, small letter D. What of this one? A. I get you now. Small letter A, B, small letter B. This is what we call equilibrium what? Constant. Now, for endothermic reaction, in an endothermic reaction, now, if you increase the temperature, what happens to the equilibrium constant? It's going to increase. What happens to the reaction? Also, it will shift to the right. That's it will favor forward reaction. This is right hand side. This is right hand side. If you shift to the when symptoms are going right for you, it means you are increasing, you are progressing, you are moving forward. I've used different synonyms. Am I going to get it now? Oh yeah, let's go now. Now that more products will be formed. That's the meaning. More products will be formed. To the right, forward, and to the right. They are the same thing. I get it now. And the equilibrium constant is going to change. It's going to increase also. Please, what of exothermic now? Okay, now similarly, what of opposite now? If you now decrease the temperature, what's going to happen? It is to the left. Opposite is going to everything now. If you are putting more effort into something to pass an exam, you are going to pass very well. I get it now. But when you reduce your effort, you will be going down. So now when you decrease the temperature, it favors what? Reverse reaction. This is what we call reverse. That's backward reaction. That's left hand side. This will not go right before you are here. And the equilibrium will shift to the what? Left. And what happens to the equilibrium constant also? The equilibrium constant will also what? Reduce. The equilibrium constant will also what? For endothermic reaction. Am I going to get it now? What about for exothermic reaction? Now, hope you have digested exothermic reaction very well now. Any question? You have digested very well, right? Now, we are working on how temperature affects equilibrium. We do for both endothermic and what? Exothermic. So now for exothermic now, we don't have for concentration is only one. Pressure is only one. But for this temperature, because temperature, when your temperature is increasing, it means you are absorbing it. But when temperature is reducing, you are emitting it like burning now, it's emitting to the surrounding. Okay, exothermic now, for exothermic reaction,
an increase in temperature favors the reverse of backward reaction.
Now, everything has, there is always opposite for everything. There's always what? What's more of exothermic? When it is being given out to the surrounding, right? Now, increase in temperature for exothermic. You know, exothermic, it favors forward reaction, right? Or reverse reaction. For exothermic is opposite. Therefore, it will favor backward reaction. It will favor what? It will not favor forward reaction. So once you have known endothermic very well, know that for exothermic is what? Opposite of endothermic. Now you have to know it. Favor backward reaction. So therefore, instead of the equilibrium to shift to the right, it will not shift to the right. It will shift to the what? To the left for exothermic. Now, For endothermic, decrease in temperature, endothermic, we favor the left side, which is the backward reaction, right? For endothermic, but for exothermic, it's opposite. A decrease in temperature for exothermic will what? We favor forward reaction, which will yield more product, and equilibrium will shift to the what? To the left. What up to the equilibrium constant? Now look up. Exothermic, when you increase the temperature, equilibrium constant is shift to the equilibrium will shift to the back, right? Equilibrium constant also will decrease. Are you getting now? Now for decrease in temperature, equilibrium will shift to the what? To the right. Are you getting now? So what happened to the this will be right. What now happen to the it should to the right, which means more product will be forward reaction. Equilibrium constant will also what? Increase for exothermic. For what? Now I want you to do something. I want to analyze this for me. Mr. Abisef, for an endothermic reaction, now when you increase the temperature, increase it will what? Endothermic reaction. Equilibrium favor forward reaction, and forward reaction is always at the right, right? It is favor now, that, and what happens to the equilibrium constant is going to what? Increase. But when you now decrease the temperature, it will favor what? In favor of backward reaction. Equilibrium constant what? Decrease, right? And we go shift to the left. Oh yeah, now. Oh yeah, tell me exothermic reaction now. It's opposite. For exothermic reaction, sleep into for exothermic reaction, equilibrium will shift. If you increase in temperature, it is backward reaction. The equilibrium constant also decrease, right? When you increase temperature for exothermic, right? When you now decrease temperature for exothermic forward reaction, and equilibrium constant was what? Increase. Am I going to get it now? Now let's now go to pressure. Pressure now. Pressure. Okay, before pressure, oh yeah, let's look at some endothermic reaction and some exothermic reaction. When you are reacting nitrogen gas and nitrogen gas to form ammonia, is an exothermic reaction. When your ammonia and when your nitrogen gas and hydrogen react together to form ammonia, the first reaction is what? Exothermic. But if your ammonia wants to form nitrogen gas and hydrogen gas back, the backward reaction will be exothermic. The backward reaction is what? This is what? So for what? Sulfur oxide. When you see CO2, what CO2? Sulfur oxide. When you see SO2, sulfur oxide. Sulfur, look at that girl. Sulfur oxide, reacting with oxygen to form sulfur oxide. That's now what? Exothermic, right? Now, if this wants to decompose back to form oxygen and sulfur oxide, the backward reaction is what? Exothermic. Everything now. Now, out of this one, hydrogen gas and oxygen gas to form water or vapor. That's what? Exothermic reaction. These are examples of exothermic reaction. What of endothermic reaction? Nitrogen gas plus oxygen gas to form nitrogen 2 oxide. When you see CO, that's what? Carbon 2 oxide. When you see SO, that's what? Nitrogen what? 2 oxide. That's what? Endothermic reaction. Now that which means it should be applied. The system needs to eat to form what? This product. I let you get it now. Now for this one. Nitrogen what? 4 oxide. I said it last time. This is nitrogen what? 4 oxide. To form what? Nitrogen 4 oxide. So this system is what? Endothermic. Yeah, this reaction is endothermic reaction. What of this one? This means what? Phosphorus. Now how are we going to do it? Phosphorus has oxidation of 5 or -3 or -5. Look up. You want to name this thing. You are going to say phosphorus. You don't know the oxidation state. We are going to do that after this topic. That's the next topic. Chlorine is what? -1 times 5 equals what? 0. A compound, oxidation state of a compound is 0. Now, so therefore, this is now what? P, this is -5 equals to 0, right? P is what? 5, right? I will say phosphorus 5 chloride. Because of the oxidation number is 5. Phosphorus what? Phosphorus 5 what? 5 chloride. What of this one? PCl3, if I want to name it, how can I name it? I'll say P, I don't know it. Chlorine is what, 3? What's the oxidation state of chlorine? -1, right? I'm having 3 chlorine times -1. I get it now. Equal to 0. Esther. Now that is now what? P equals to what? 3, right? Now this is what? Phosphorus what? 3 chloride. Phosphorus. 3 chloride. Chloride. I don't get it now. And chlorine gas. I get it now. So it's an endothermic reaction. This is an endothermic what? Oh, successfully we have learned effect of temperature. Am I going to get it now? Now we are going to go to effect of pressure. And pressure only affects gaseous reactants and gaseous products. When I say gas, when I have gas reactants and gas products, I mean when I'm a reactant, the state is what? Gas. And the product, the state is also what? Gas. That has when pressure is going to have what? Effects. It does not have effect on liquids, it does not have effect on solids, reactants or solid products. Am I going to get it now? Oh yeah, let's go now. Wake up. Oh yeah, pressure depends on what? Oh yeah, class, read. Even the pressure chair, Greater condition, that's product and reactants. Now, Boyle's law. State Boyle's law for me. Boyle's law tells us about relation between pressure and volume. Who can state Boyle's law for me? This is Boyle's law, right? We have step for a given what? Mass of the gas. The pressure is inversely proportional to the volume. Whether that other or temperature is made what? Constant. Now, what's the meaning of this one? If the pressure is high, the volume will be small. Or if the volume is small, the pressure will be high. Look up now. If I'm having a gas container now, this gas container, a very large gas container, look up. When we are dealing with pressure, let's assume space. Let's assume what? Space. Now, this gas, are there many? Are there many in this container? There are not many, right? So therefore, the volume of this container. Now look up now. Does gas have a specific volume? They take the volume of the container, right? Now look up now. Because of this container is wide. When the volume of the container is wide, the gas particles are not freely. They are not restricted. The pressure on them is not much. The pressure on them is not what? If I now carry all these gas particles, if I transfer them inside one small container, is this volume very large? Small volume, right? Now, the volume is very, very small, right? Is there pressure on those gas particles? Yes, because of pressure freely, right? Now, small volume, high pressure. Small volume. If this one is small, this one will be high. If this one is small, this is exactly nothing. This one is small, this one will be high. Because of this space is not that much for them. They have small body. So therefore the pressure was high. Like your lighter. Now it's not a gas lighter. Because of those gas particles, there will confined very small space restricted in that small container. Actually you can see them, they will be liquid. But paint that thing. Explain to the air. Air is large volume, right? they will move freely, they will escape to the negative now. So therefore, large volume, low pressure on them. Large volume, low pressure on them. Hope you can see what I'm saying. Oh, can you see what I'm saying? Musa, you can see what I'm saying. You know, see, you cannot see with naked eyes. So you see what I'm saying, right? Okay. So now you have understand pressure and volume now. Look up now. So which means if there is more volume, it means pressure is what? High. If there is high volume, pressure is what? Low. So pressure for those gases here is low because of they can move freely. That's why the pressure is low. But those gases here, they cannot move freely. There is high pressure on them because of they are in a small container. The volume is very small. Am I communicating now? Wake that girl up. Wake that girl up. The lower pressure, the more the volume, the smaller the pressure. The more the volume, the smaller the pressure. If I carry those gas particles now, if I transfer them to drum, if I transfer those gas particles now, if I transfer them to drum, big drum, there's no pressure, they can move everywhere, they move everywhere. Pressure happens when gas cannot move very well in a free space. Yeah, the size of the container. The size of the container, I get him now. Now the size of the container. So there is more space here. There is more space here for them to move. I get him now. So therefore they have a larger volume here. So that's why they have a smaller pressure. So this is an inverse relation. This is what an inverse relationship. So if there is larger volume, the pressure will be small on them. But if there is small volume, the pressure will be what? High on them. Because of small volume, the pressure is high on them. So now, if I have a bigger one, I will have smaller pressure here. Oh yeah, look up now. So I want to understand it very well. Let's now come to this place now.
An increase in pressure.
An increase in pressure. Now look up in this thing now. Hey! We normally use this mole here. We normally use this mole here for as a volume equivalent. This is what? 2 what? It's even here. 2NO, right? Now 2NO2. What is the number of mole here? 2, right? I'm having 2 volume. I'm having 2 volume here. 2 volume. I get him now. Equivalent to what? 2 moles. What number of mole here? 1. This number beside this product. That's 1. Amaka. 1 mole. I'm having what? 1 volume. Now look at it. Look at the question now. An increase in pressure. An increase in pressure will favor what? An increase in pressure will favor direction with decrease in volume. Please. Rebecca, come and sit down here. An increase in volume will favor what? A place where there is a decrease in volume. An increase in volume will favor where there is a decrease in volume. Because there is what? One time by inverse, if one is increasing, one is decreasing. So now when increase the volume or when increase the pressure of the system, it will this equilibrium will shift to where we have a lower volume. When increase the pressure of the system, the equilibrium will shift to where we have what? A lower volume. And we have a lower volume here, right? So now for this gaseous system, and increase the pressure will favor what? Forward reaction. You want to have a lesser volume here. What we have a lesser volume here. What we have a what? A lesser volume here. Now, so read it again.
An increase in pressure will favor the direction with a decrease in volume. Now, equilibrium shifts to the right. Changing the direction we go.
I get him now. Okay, look up. Nitrogen gas. Plus what? Oxygen and hydrogen gas will give what? Ammonia. What's the volume I'm having here? 1V, right? What's the total volume I'm having in the reactant side? 3 plus 1. That's 4V, right? Increase in pressure system in favor where? Where we have a lesser volume. Where we have what? Or where we have a lesser number of mole. Or where we have a lesser number of what? Mole. The number of mole is equivalent to your volume also. In favor forward reaction because you have a lesser volume here. So when you increase volume pressure of the system in favor where you have what? A lesser volume because there is an inverse relationship between what? Pressure and what? Volume. P is directly inverse to what? 1 over V. I get him now? Directly inverse to volume. I mean, is inverse proportional to volume. I mean, so that's just it. That's just it. Similarly, what of decrease in favor backward reaction? Like that's it. Now, a decrease in pressure. A decrease in pressure. A decrease in pressure will favor when we have a larger volume. So if I decrease pressure of this system now, it's going to move to where I have a larger volume because there is an inverse relationship between them. If one is increasing, one must be decreasing. If one is increasing, one must be what? So a decrease in volume here will favor when we have a larger volume. Now, if I decrease the pressure, a decrease in pressure, I mean, if I decrease the pressure system now, where would the equilibrium shift to? In the favor what? Backward reaction, right? Because I have a larger volume at the back. I get him now. Please take notes. They can come in any form. They can come in what? Oh yeah, now. Read. If the reversing reaction has the same number of mole, both at the right and the left hand side, both reactant and product, if they have the same number of mole, these are what we call mole. All these numbers we can see at the beginning, like a coefficient of a letter. They are called what? Moles. So now, if they have equal number of mole, so therefore, there is no effect of pressure. Pressure will not affect that system. Pressure will not affect what? That system. Now, look up now. Where are your gases here? Where are your gases here? Is this not a gas? Where is your gas in product here? Hydrogen is a gas. H2O here is the steam, right? Vapor, water level of vapor, right? This gas. So pressure does not affect solid. Pressure does not affect what? Solid. Pressure does not affect what? Solid. You only deal with the gaseous reactant and gaseous product. Now, how many volume of gas do I have here? 4. How many volume of gas do I have here? 4. Pressure has no effect on this system. Pressure has no what? Because of number of volume here of gaseous reactants is also equal to number of volume of gaseous products. Number of mole of the product is equal to number of mole of what? The reactant. In that kind of reaction, when you see to your question, pressure has no what? Effects. Pressure has no what? Effects. Is it your TB2? I don't try to see your guy. Please take notes. We are making progress. Those factors are very, very important. And the next one is what? Instead of concentration. Say concentration. Say concentration. If I have milk in my tea, I have milk. I have 30. Okay, I have milk. I have sugar to form tea, right? To form tea. Example. Always have said sometimes. If I have milk, I have sugar to form tea. If I take part now, if I take part of those sugar, I take part of those sugar, I have reduced the concentration of the system, of the reactant. I have what? Reduced the concentration of the what? If I take part of the milk also, I have reduced the concentration of the what? Reactant. It's just like when you put water inside minerals. Your soft drink, I mean. What's going to happen? It's not be like original one, right? By that, you have reduced the concentration. I get him now. Maybe salt, maybe Maggi. You put like 20 Maggi. You now go ahead, you now use separation technique to extract like 3 Maggi out of it. You have reduced the concentration of that one, Maggi. When you are taking part of it, you have reduced the concentration. Am I forgetting now? Okay, yeah, let's go on ahead. Now, concentration is very simple also. We have got the pressure, we have got the temperature. When you increase concentration, I get it now, of reactant. What happens? When you increase temperature, concentration of reactant, like when you add more reactant, when you add more reactant, what happens? More product will be what? More product will be what? And product will follow the reaction, right? So it will now it will shift to the right. To the right, right? That follow the reaction will be favored. When you add more reactant, means you have increased the concentration. Okay, look up now. When you now remove some products, that is in equilibrium. When you now remove some product must not be more than reactant. If something is in equilibrium, when you now remove some products, what's going to happen to the reaction? When you decrease the concentration of the product, more reactant will be coming to item now. Now, when you decrease product, what's going to happen? Now, good. But I will go up now. Decrease the what? Now, look up. If I'm having 2 mole per dm cube of milk, I'm having 3 mole per dm cube of sugar. I get it now. And I'm having 5 mole per dm cube here. Look up. If I take 0.5 mole per dm cube of sugar away, that's I'm explaining where am I now? Decrease concentration of the reactant, right? Now if I take, because this one I'm already equal number of reactant, equal number of food. Okay. If I take 1 mole, maybe 1 mole away from this place, out of the sugar, yeah, you know there's sugar in this tea also. Some of it will come to and replace what I take. If I take maybe 1 mole per dm cube of sugar away from it, what I take here, some of it of the sugar will come back to come and replace what I take here, because there must be balance. There must not be deficiency. One must not be more than one. That's the logic here. One must not be more than what? So if I take part of it out, so the one part of the sugar that has formed here will now come back here and replace what I take. So I get it now. So if I decrease the concentration of reactants, equilibrium will shift to the what? To the left hand side. Decrease, left, decrease, backward, decrease, backward. When you are decreasing, you are going backward also, right? So if I decrease concentration of the reactant, equilibrium will shift to the what? Left hand side. Am I going to get it now? So now, when you decrease the concentration of the reactant, equilibrium will shift to the what? To the left hand side. Decrease in concentration of the reactant, what is the equilibrium to shift to the what? Decrease left, decrease back of our reactants. I get it now. Where our volume we see ahead. Look up. This one must not be more than this. If I add increasing concentration of the reactants, adding more steam, when you add more steam, you still pour more steam in this reaction, in this reactant side. You pour more steam here, you have added more steam. And I told that one must not be more than one. What happened? You have decreased the concentration of the reactants, right? So because of they have increased it, part of which we what? We form products. So therefore, equilibrium will shift to the what? To the right. Equilibrium will shift to the what? So this one will give part of it to this face. So they must be equal. They must, that's what we call equilibrium, balance. Am I getting now? So now, adding more steam will increase the concentration of the what? Of the reactor. So therefore, equilibrium will shift to the what? To the right. Am I getting now? Removal of what any member of the product will do likewise. If I remove hydrogen gas, remove hydrogen gas here, I am reducing the concentration of the product, right? What's going to happen? Reactor to what? Supply. So that this one what? This hydrogen gas be formed back again, right? So when you reduce the concentration of this product here, reactor now they will be forming products, which means the equilibrium will shift to the front, to the right hand side. That favors what? Forward reaction. Am I getting now? Okay, well, let's go now. Come back. This is the head of it. When you move iron and you added more to this one, that's partial. When you move iron and you added more to it, what's going to happen? It will shift to the what? To the left. So favors backward. This backward what? Reaction. I get him now. Yeah. Good. Look at questions. Say that sentence was equal. We have said it. Look at question. We are class. You are going to answer question yourself. And you should have one subtopic, which is equilibrium constant, right? You are going to answer question yourself. Consider the reaction extended by the equation below. Hydrogen gas to form what? Hydrogen iodide gas, right? Is what? Exothermic reaction, right? You have to be checking this thing. When it's negative here, that's exothermic. It is being given out. It is being lost to the surrounding. Which one the following take place? When the temperature of the vessel is decreased, exothermic. You can first remember endothermic. Endothermic, when increase temperature, in favor what? Forward reaction. When decrease temperature, in favor backward reaction. But for exothermic, when increase temperature, it's not going to favor forward reaction, it's going to favor backward because it's the opposite of endothermic. Now, when the temperature of the vessel is decreased, exothermic, when increase temperature, it's going to favor backward reaction. When you now decrease temperature, it will favor forward reaction. There is a decrease. If what following take place, if the temperature of the reaction is what? Is decrease. That forward reaction will be favored, right? Now, which means more hydrogen iodide gas will be formed. The gases condenses, the yield of hydrogen increases. I love this question. Concentration of the reactor remains constant. More of the hydrogen iodide gas decomposes. When you say something favor forward reaction, means more product is formed. If something favor backward reaction, more reactant is formed. That's the meaning. Now, for exothermic, when you decrease temperature, it will favor forward reaction, decrease in temperature, which means more product will be formed. More hydrogen iodide gas will be formed. Now, look up. What's the answer? Option A to E. Yield. What of yield? Produce. The yield of hydrogen iodide gas increases because this hydrogen iodide gas are the product side here. I get it now. When you decrease temperature of this exothermic, more what? With the favor forward reaction, which means more iodide gas will be produced. So the yield, which means the production of iodide gas will what? Iodide gas will what? Increase. I get it now. That's what? Option what? Option E. Am I communicating now? Am I communicating? If you are saying at this moment something is wrong with you, if someone is sitting beside your side, wait that person before I get to your side. If you are saying at this moment something is wrong with you, in deliverance. Now, I love this question. Even a decrease in pressure, when there is a decrease in pressure, it will go to where we have a larger volume. If this one is decreasing, volume must be increasing, right? In the reaction of the effect of decrease in pressure, Unequal position will lead to what? Decrease in the amount of oxygen produced. Option A, you know, wait, look up now. These are gas, right? How many moles do I have here? What's the volume? 3 volume, right? 3 moles, right? Total, right? 1 and 2, 3. How many moles? What's the volume here? Where do you have larger volume? Product, right? Which means if I decrease the pressure, it will form, go to where? Now the reaction will go to where I have a larger volume, right? The product side. Which means more of this will be what? Formed, right? Okay. Now, if there is a decrease in pressure of the system, there will be decrease in the amount of oxygen produced. No! Which means there more oxygen will not be formed. Which means there will be reduction in the production of oxygen. No. Decrease in the amount of sulfur oxide produced. No. Decrease. No. Amount means mole or volume. I'm not going to now. Let's have volume. I get it now. Increase in the production of sulfur oxide. Where sulfur oxide? Product side. Sulfur oxide. Will there be increasing? When you decrease pressure, it will go to where you have a larger volume, right? Like mean more of the product will be formed. There will be increase in the production of what? Sulfur oxide, which is option C is what? Is the right answer. I get it now. There will be what? Increase in the production of what? Sulfur oxide. Look at this. No change in the concentration of both reactant and product. No. No effect of no. So now, increase in the production of what? Sulfur oxide. I get it now. Now look up. Also, option C and E is likely to be correct because pressure does not affect equilibrium constant. It's only temperature that affects equilibrium constant. When I was teaching, I didn't mention concentration and pressure affect equilibrium constant. Pressure and concentration does not affect what? Equilibrium what? Constant. It's only temperature that affects what? Equilibrium what? Constant. Now, no effect on equilibrium constant. Still correct. I get it now. But there will still be increase now. Production of sulfur oxide, not only sulfur oxide and oxygen also. As when they have put oxygen, this will be the most accurate. Your exam is about picking the most accurate answer. You might see two options that look alike. Yes, there will be increase in production of sulfur oxide. How about the other product? It will be for the two product. There must be increase in production of oxygen. They didn't put it there. So which means option C is not the most accurate answer. So option E is the what? Most accurate what answer? No effect on what? Equilibrium constant. Pressure does not affect equilibrium constant. Okay. Pressure does not affect equilibrium constant. The only thing that affects equilibrium constant is what? Temperature. I think they have put sulfur oxide and oxygen. Is very correct also, right? But they didn't put oxygen so that you can be confused. So that is about what? Accuracy. So now option E is the most this is correct, but this is the most correct what? Answer. That has no effect on equilibrium what? Constant. Good.